Welcome developers. In this video we will learn how to flat a given array. But in this video we will learn how to implement a custom flat polyfill function. So you must note it whenever I call the function array.flat. So you must know how we are able to call array.flat, because we don't know how flat is applied on the array like this internally, right? So if we are able to write our own custom flat function that should work on every array like this flat function, those function snippets are called polyfills. Those snippets are helpful, or we can call them as a patch or a fix for the older environment or older browsers, the browsers which does not support some modern features. Generally Internet Explorer does not support find functions and ES6 functions, so we can write such snippets so that it should work in old browsers and all. So we will write our own custom polyfill called flat. We will call it as a myFlat. Before I move ahead, let's understand few things about the flat. If I pass 0 depth here, so nothing should change to the given array. It should stay neutral. Let me show you the output as well. Let's remove everything. So as you can see, nothing had changed to the given array. We are not able to see if the depth is too high. As you can see, the here after the 8th, these numbers are not visible because here the depth is too much. That's why we are not able to see. So if I put here infinity, so as you can see, all of your nested array wrappers should be removed. All the elements should come at the top level in the given array. As you can see, we got it. So this is how you can implement a built-in flat function. So we have to write our own custom myFlat polyfill function that should work in all kind of environments. Let's write a myFlat first. So before I write a polyfill function, you must note it. First condition should be whether that function myFlat or flat either exists or not in the current environment. We have to write such condition first. Let's check first. So we will check, because we are applying the methods on the array. So we will check in the array constructor in their prototype. Here we will write our own flat, let's say flat. So if it is existed, or if it is not existed in an environment, in that case we will write polyfill here. We can give any name here. Let's give myFlat, that's better. Let's say myFlat. So let's declare this myFlat in the prototype of the array if it is not existing there. So here we have declared myFlat. Here we will pass a anonymous function which will receive what we are passing here, a depth, that will receive the depth only. Here we got the depth. So what will be the first condition according to you? So for me the first condition should be if the depth is less than 1. In that case, let's say depth is less than 1. So we should return the array as it is. Array here we will call it this. This is going to be your array. So the value of this depends on the function. It's a regular function, right? So we are calling this within the regular function. So the value of this depends on the how myFlat or regular function is called. So as you can see, myFlat is called on the array. So this is going to be your array. So in this case, if the depth is already less than 1, that means 0. If I pass 0 in a flat function, your array should not change. It should be neutral, right? So that's why we are just returning the array as it is. Now the second condition will come here. First, let's declare few variable. Let's check length first. Here, your this dot length should always be greater than. We will use right shift here so that our length should be a positive number. It should not be negative, so we can check it like that. Again, it is going to be length, a positive number. Here let's have some result or a empty space for holding the flattered items, right? So here is the main logic. Here we will iterate over the given array and we will flat them using recursion or something, right? Let's say I0, I less than your length, and I plus plus. Here we will write our first condition. As we know, the first condition for this, it should be if the item inside the array. If you see here, the item inside the array, if it is an array, how we can check whether it is an array or not? Array dot is array. It's very easy. Here we can put our item. How we can put? Let's say This we already know, this is our array. Here we will check if it is an array, and the second condition should be your depth should be always greater than 0. So this is going to be your first condition when you are passing a numerical parameter in the myFlat. What if we are passing infinity? Because infinity means we don't know the number, how large it is. So infinity means infinity. We cannot even decrement it in, nor we can increment it. So what we can check here, one more condition, either depth is greater than 0 when it is a numerical. When it is infinity, we cannot do anything. So what we can do, we can use logical or if your depth equal to infinity. So we will pass this condition in both the scenario, right? So here what we have to do, we will call a flatted, we will use this variable to hold the flatted items. So let's call this myFlat here recursively. How we can call? Now this is the condition. As you know, when we are declaring function here in the prototype of an array, so myFlat will be available out of this scope, as well as we can directly call now this myFlat function on the given array. So we already know this and this item, right? This is now again a new array according to this. This is an item. Here we can call myFlat function recursively, and here we can pass depth. So what should be the depth here? Now the main thing again, if the depth is infinity, so here we will write, let's say if it is infinity, we'll use ternary operator. So infinity nor can increment nor can decrement, it will be as it is. But here your depth should be decrementing depth. So here you will get the flatted array. Again, if you have the flatted items, you can just post these items in the result array by just looping over this. It's very simple. How we can do that? It's very simple. For let's say take const here. Let's say itm of, and let's say flatted array. So make it flatted, not faulted array. So here flatted array. So we will get the item here directly. So simply just post to the, very easy. So it is going to be item directly now. So this is how you can handle this condition. You must note this is a post condition when item has flatted here. So we will loop over that. We can push into the result array directly, right? So here what if this condition doesn't match? When it is not an array, right? When the depth is either both the condition is failing here. So what you can do here in the else, that means when it is not array, it is an item, right? So we can just post it directly, make it as a your this and I, right? Yes. Now we got the array, and at the end here just return, let's say here we have, here you can just return your result very simply. Now let's check your polyfill whether it should work or not. myFlat, let's check it once. We are calling myFlat with infinity. Now let's run it over here. So as you can see, it is working as expected. myFlat is working like a built-in flat function, right? Now let's pass 2 as your depth. So what should happen? Let me see the output now. Here let's move up. So as you can see, when we pass the depth 2, so 3 4, the first array here, this wrapper is removed and this wrapper is also removed. Now the last wrapper, this should be remaining, right? 8 10 11 should be inside this, like 8 10 and 11. This wrapper is still pending. So this is how a custom polyfill flat function works. So this is how you can write your own polyfill of flat function.